Hello and welcome to my channel. Today again we are going to compare ArrayList and LinkedList. So operations that we are going to compare are insert, then search, and then delete. So in one of the last videos we have seen that ArrayList was performing better whenever we were trying to insert element in the middle of the ArrayList, and whereas linked list was taking some of the time. So the root cause we are going to analyze today. So this diagram you can see. We are going to divide or going to perform uh, this insert, search, and delete operation in on three different areas. The first area is which is going to be near to the start, or we can say head pointer in the array linked list, and maybe from the zeroth index in the array list. The second it is going to be the central part, where some we are going to perform these operations around somewhere around middle of the linked list and array list, and in the end we are going to perform same operations uh, near around tail area of the linked list, and the last part of array list. So we are going to see some interesting results over here, so please stay tuned. So first of all, let me show you the code. So this code I have taken from Stack Overflow, and the purpose was to identify the root cause why what why linked list is supposed to perform better, but still we were getting better result for array list in some of the cases. That's the reason we have done this video. Okay, so to start with, we have this test class, we have this random function. This random function we are going to use to generate numbers in random numbers somewhere in between the given range. So we have used this upper bound, lower bound. Soon we'll be finding it how we have used. So first of all, we will be taking some simple scenario. That is the start. We'll be comparing array list and linked list for these three operations for the start of the so we'll be considering area which is going to be start of the data structure. So we'll see the how the code is written. So here we have created objects of array list and linked list. We are putting some dummy data. So in dummy data we are putting as much as this much data. So it's around 20 lakh of data we are adding. Then what we are doing is we are going to perform insertion operation. Insertion operation, what we are doing is we are iterating from around 200 to 0, and here this is the important function where will be this is the start. Okay, so what we are going to do, we are using the random function, and we are creating random numbers from 0 to 1000. And so what will happen is here during insertion, once we have array list or linked list with dummy data, we are going to perform random insertion from 0 to 1000 index. So that what will happen is uh, will be performing this insertion operation from 0 to 1000 node. We'll be getting it through random function, and we'll be performing it in a loop for 200 times. Okay, then same for the finding, that is the search operation. We are using get function, and we are again doing same thing. We are iterating this for loop for 200 times, and we are calling this random function, uh, where we are setting it to bound to 1000. Okay, and same with the deletion operation. So deletion we are using remove function. You can see the whole loop is same. I mean, this function is same, except this remove function. For finding, its get function, and for insertion we are using add function. And this list, so fortunately the linked list and array list both implement this list interface. Okay, so enough about the code. Now let's start with our testing. So I'm going to start with first scenario where we will be performing operation at the initial area of the linked list, and clearly we can see here ArrayList is taking more time during the insertion. Then for searching, no problem. Removing, again, ArrayList is taking more and more time. So clearly here linked list is the winner. Okay, uh, and ArrayList is taking time for insertion and removal. Okay. Also, thing here to note is linked list is taking very much less time for searching. Okay, so it's almost taking as much as time, same time as ArrayList. So this is something we should note. What So I'm going to explain why this is important. The searching operation on of the linked list is very critical. Okay, now let's go to second scenario. What is the second scenario? Second scenario is so let's try with tell function, and then we'll come back to this middle part. Okay, because last part is very easy. So in last part, what we are going to do is simply we will be modifying this random function. This random function will be using will be basically creating 0 to 1000 random numbers, and then we are going to add this offset, which is count total number of objects minus 1000. So that will be getting random objects from last part of the array list and linked list. Okay, so this is a simple math function. Okay, so what the purpose of this is, we should get random values of the index number from the last part, last 1000 nodes, or 1000 numbers in indexing array list. Okay, so let's continue and see what is the result. So far we have seen array list was a loser in first scenario. Here again we can see array list is performing, so it's quite the performance is same, or rather I would say slightly ArrayList is performing better. We are trying we are trying to insert, delete and find element at the end. Okay, so here again what we are seeing is ArrayList, the performance is quite same in this case. So almost win-win scenario. So now interesting part here is why ArrayList is doing something like this is because we are at the end of the we are at the end of the uh, uh, we are at the end of this part. And ArrayList, what happens is ArrayList uses array copy function, as we have seen in last video as well. So what happens is ArrayList, only some part of the data it needs to move. So that's the reason it could be almost as fast as linked list. Okay, and what happens is in initial part you have to move this much area, right? So larger part of area it needs to remove. Hence, I believe the performance of the array list is not getting hampered. So now let's go to last part. We'll be adding uh, performing operation in the middle of the linked list and array list. So yeah, this is going to be interesting. Let's see what is the value of upper bound. So this is, and so I'm dividing this total count obj to with 70% and 30%. So so the value comes as let's do a simple math. Yeah, so if I do star 0.7, then it comes 14,000. Okay, and similarly if I do zero point 0.3 multiplication, then we get 6,000. So we should, so what I want is to generate random index in between upper bound and lower bound, that is 6,000 and 14,000. So that so that uh, so assume that this area, so the starting index, the values index I want to generate random index is it starts from 6,000 to 14,000. It's somewhere around the center. Okay, so now we'll be testing. Let's see what is the result. Let's run this code. All right. Uh, so ArrayList took around 228 milliseconds, and now we are seeing the linked list is taking a lot of time. Okay, so we'll run one more time. So in all three cases, linked list is loser, and we are going to find the reason why. So insertion very easy. ArrayList is beating up very quite comfortably linked list. Okay, so we are seeing that insertion is happening. All these three operation, insert, delete, and search, ArrayList is performing better when we are considering center area of this data structure. The reason, now I will tell you why. It's because the performance of linked list is mainly depends on the node, the distance of the node from head or tail. Okay, it's because it takes time for ArrayList to traverse from either of these, because linked list is a doubly linked list, right? Internally we have head and tail pointer, and so worst case scenario for linked list, if the element is somewhere around center of the data structure, center of the linked list. So what happens is when the time, so actually the insertion or deletion operation is happening faster than ArrayList, but the time taken to reach that node is also we have to consider. Okay, so if the scenario is like this, if you calculate the time after, let's say we are doing benchmarking after reaching to nth node, so if consider insert operation or delete operation, then definitely linked list would have bit ArrayList, that we have seen here as well. Okay, head and tail, because in head and tail operation linked list was not taking much time for search operation. So here, that's the reason what I when I said this search operation is very critical for linked list. If searching is happening very fast, then it should be able to and remove and insert at very fast. So it's because it's actually very fast for linked list, but the time taken for to reach that node, that's the reason it appears that linked list is doing this operation very slow. Okay, so that's it from this video. Thank you for watching.